Sure. My name is Hamid Tizhoosh. I'm a member of the Faculty of Engineering at the University of Waterloo, and I'm the director of Chemia Lab and a faculty affiliate to the Vector Institute. My research field is medical imaging and the usage of AI in medical imaging. Image search is exciting because image search is the core part of the image search is unsupervised learning, so you don't have the benefit of training something with millions of instances of data. So the actual part of the search is done unsupervised, although you may use features who have been trained. So that makes it really exciting because we know that unsupervised learning will be a big part of general intelligence that we are trying to move forward. And working with industry is very important for us, everybody who is involved in AI, because we want to show that AI is actually capable of solving real-world problems. So not just for labs and theoretical work and conferences, but also we go out in the real world and we find instances like digital pathology. And in that, we work with industry to work to find solutions. So it was early 90s that my supervisor pushed a paper in my hand. That was the famous Rumelhart-Hinton paper, and I had to implement that in ANSI C. And basically, neural networks stuck with me, and since then I have been using some type of neural networks along the way. And when Jeff Hinton came back and created, with other colleagues from UFT, created Vector Institute, that was clear that everybody in the field liked to be part of that. So that's a very exciting opportunity. A lot of talent guided and attracted by Vector, and it's definitely an honor to be part of Vector Institute. So at the moment, we have achieved a lot of success in certain fields, especially in computer vision and maybe natural language processing. But everybody in the field knows that there is a lot of work still to be done. And as I mentioned, we definitely have to move toward unsupervised learning, and the type of layered feed-forward network, in my perception, we have to get away from that and go toward more connected graphs with more capability of connections. To be able to recognize and store patterns. That's definitely something that we have to work on. So there is a lot of work ahead. So we are at the very beginning, but the recent success stories of AI definitely help to get attention, talent, and resources to move in that direction. So our recent grant from Ontario government, who supports, along with our industry partner here on Digital Pathology, we are supposed to use AI in digital pathology to develop an image search engine. So there is a tremendous number of images that are available. They are associated with pathology reports. There is a lot of knowledge in those reports, but there is no delineation or marking or labels in the images. So it requires a lot of intelligence to match the reports and images and to create an image search engine that through visual search combined with textual search, doctors, pathologists can lay back and use the existing knowledge for research, for educational purposes, but also in order to make better diagnosis, faster and more efficient diagnosis. So we will work in that direction for the next 5 years.